I hope you can all hear me, hopefully. So today I'd like to speak to you about byproduct utilisation and resource utilisation in the food industry. And this is important because basically when you're producing food and processing food, waste is both an economic and an environmental cost. But more specifically, it's very important in terms of three points. Food security. Now, why should we harvest food and then throw away half of it when by 2030 we will require 50% more food to feed our global population? Secondly, environmental regulations and reformed agricultural policies and fisheries policies mean that it's important to utilise all your discard or waste. And thirdly, a lot of companies have signed up to Board BS initiative Origin Green, and they've committed to reducing their waste streams by 15% by 2017. So when you eat your steak or your lamb chop or your pork chop or your fish, there is a lot of edible waste, if you like. I prefer to call it byproduct or co-product produced, okay? So for example, in the cattle processing industry, one of the largest waste streams is blood, followed by liver and edible fat. It's the same story in the pig processing industry and in the sheep and lamb processing industry as well. Blood is a massive byproduct of production. Now, blood does have certain markets. For example, it's used as blood meal. But by using science and technology, we can actually derive high-value added products from blood. And I'm talking about proteins here, really, and further bioactive peptides. In the marine industry then, in terms of fish processing, when you process a fish and discard is produced, and up to 30% of that fish consists of protein that's not used currently. Ireland is an island, and we're very blessed because we have very clean green water, or clean waters, and within these waters we have up to 300 different species of macroalgae or seaweeds, and as Ross Campbell alluded to earlier, 24 of these are actually recognised as sea vegetables, but we're not using them to generate high value added products, and we're not even using them as basic vegetable ingredients either. In terms of deriving value-added products, I think protein has great potential, as you probably know if you're in the food processing industry. These graphs here show that the increased global population, basically we need to produce a lot more protein to feed this population. And it's also predicted that by 2054, about 33% of the protein that people consume will be alternative proteins, so proteins derived from non-dairy and non-meat sources. Also, in terms of trends and consumer trends, which are obviously very important and should drive innovation, there is certain sectors across the globe are more open to new ingredients. So the Chinese are recognised as being the most adventurous in this area, and also up to 30% of Europeans will try a different marine protein source. So, as I said, we have this problem, or we have this benefit, if you like, of processing in food industry. In terms of meat and fish processing, we produce byproducts such as skins, blood, things like that. And from these sources, using science and technology, we can develop high value add proteins and high value added products for the functional foods market. And here I'm specifically talking about bioactive peptides. So you might be wondering, what is a bioactive peptide? Well, a bioactive peptide is something that can be derived from a protein through hydrolysis or fermentation, and it can impart a health benefit to the consumer that goes above and beyond basic human nutrition. So it has a health benefit, and as you probably know if you're in the food processing sector, functional foods is a growing market segment. So you can also derive valuable techno-functional ingredients from these byproducts. An example of these would be collagen and gelatin from salmon skins, for example. And this gelatin and collagen has benefits above and beyond the ordinary sources of gelatin and collagen. Normally gelatin and collagen are derived from pig sources, but fish-derived gelatin and collagen has added benefits such as it has higher digestibility, and it is also acceptable to certain religious minority groups such as Hindus and the Jewish, and it's also suitable for vegetarians. That's just a little slide there on the applications of gelatin. So it can also be used in cosmeceuticals, cosmetics, and in a number of food sectors, such for example in the manufacture of jelly beans. So fish protein has several advantages and disadvantages. One advantage is that it's superior to plant protein in terms of its amino acid composition, so it could be suitable for use in the development of foods for the elderly, for example. There's a better balance of essential amino acids in there, but it can be more heat sensitive than other protein sources. In terms of seaweeds, from the 300 species of seaweeds that are found commonly around the Irish coast, the green and red seaweed species, there are 3 different categories of seaweeds, brown, red and green, and the green and red are a very rich source of protein. Brown seaweeds also contain proteins, but not to the same percentage of dry weight, okay? So these proteins can have technofunctional attributes. They can be used as gelation agents, they can be used in water binding, solubility, emulsifying and foaming in the food industry. An example of a product that exists on the market at the moment is this lipid algal flour that's derived from algae, and it's used as a substitute in bakery products. So bioactive peptides, as I said, they're basically sequences of amino acids that can impart a health benefit to the consumer that goes above and beyond basic human nutrition. But a lot of people aren't really open to taking up this idea of bioactive peptides. And I would say that that's a mistake because as it stands on world markets, there are several bioactive products that are developed from marine processing streams, and these would have EFSA novel food claims. For example, there's one product that's a sardine peptide hydrolysis product, and it has a novel EFSA food claim. So basically EFSA is the European Food Safety Authority, and they govern what claims can be made on foods in the EU. Something else we work on in terms of byproduct utilisation at Utagas is rapeseed meal. Now rapeseed is obviously processed by a number of companies here in Ireland and globally for the production of rapeseed oil, but a byproduct of this process is rapeseed meal. And in conjunction with Trinity College, we're looking at the moment at isolating 2 small molecules from the rapeseed meal. That would be cinnapic acid and PA, and these have associated health benefits as well. So hopefully that will be a successful project. Another small molecule that has functional food potential is the compound glycine betaine, okay? So this is a small molecule that's commonly found in beetroot, but as part of a marine initiative that was funded by the Irish government, Nutrimara, we looked at a number of Irish seaweeds that are found around the Irish coastline, and we looked at the levels of glycine betaine in these seaweeds, and we found a number of species that had glycine betaines. And the good thing about this is that glycine betaines are known to regulate homocysteine levels in the blood, and they're therefore thought to be good for your heart and heart health. So they have actually an EFSA health claim in relation to maintenance of homocysteine levels in the blood. So that's a potential functional food product as well. And how we generated these was in the lab, at lab scale, but it is a scalable process, I think. And basically you take in your raw material, you stabilize it using freeze drying or spray drying technology, and then you carry out a series of extractions, you dry it and then enrich and purify your bioactive. Now it's not present in large amounts in seaweeds, but it is a very active small molecule, and it is of high value on the world market, so basically quantity here wouldn't be an issue. Another carbohydrate that we looked at from marine discard sources is chitin. Now, to me, chitin is a wonder molecule. It's used in the manufacture of several things outside of food. For example, in the US, every US soldier has to carry 2 chitin bandages, and the reason for this is that chitin can clot blood, and basically if a soldier is shot, it can help prevent bleed out, okay? It's also used in wastewater treatment. It can be used to recover proteins from dairy processing, and it also has use as an anti-obesity agent. In conjunction with UCD, we carried out some research in this area and assessed that chitin can actually affect the leptin gene, and the leptin gene controls appetite. So chitin was known to help to prevent obesity and to reduce fat intake, but in conjunction with UCD, we discovered that it affects the leptin gene, so it's active at a gene level, okay? So it has several applications, and in your discard, marine processors have a big problem with discarding shell material. For example, in crab, there's up to 26.6% chitin in the shell of crab, and currently that isn't being utilised, but it can be used to generate chitin and chythin. And as part of the New Tomorrow project, we also looked at generating this chitin and chythin from prawn and crab shell material. We then subsequently fed it to pigs and assessed the pig's weight gain and weight loss, and determined its effect on the leptin gene. It is available in countries such as Spain, chytin, but nobody has ever proven that it affects the leptin gene. So that will go towards making an SA health claim on this product, because it currently doesn't have an SA health claim for weight loss. So we did some analysis on it in terms of its degree of acetylation and its solubility. And then in terms of meat and the meat processing industry, blood, the fifth quarter, is obviously a valuable byproduct. As I said earlier, it's used in the manufacture of low-value products such as blood meal, but using in silico analysis or computer-based methods, we can actually develop enzyme hydrolysis systems and protein extraction systems that can help to hydrolyze the blood proteins into high-value compounds that can affect health. So, for example, some blood proteins and peptides we've identified can affect the enzyme DPP4, which is thought to play a role in the control and development of diabetes type 2. So basically, just to sum up, because I'm out of time, you can use byproducts from marine, the meat processing and the food industry in general, and by applying science and technology, you can increase the value of those products from animal feed to human and functional food applications and potentially medical applications. I'd like to thank you all very much for your attention. I hope you could hear me, and thank you.